Please, can all the speakers from this morning come here? Rachid? Okay, please take a seat. Thanks to stay for this round table. Maybe we have maybe a quick introduction of the three people that were not speakers from this morning. I will end with Rachid, but maybe the two other ones. Could you introduce yourself and explain what you are doing, what you are working on?
Hello everyone, and thank you for welcoming us. I'm Matthieu Claybrough from Donéclé. So Donéclé is a French startup. We design UAVs for automatic aircraft inspection. So you've probably heard of us in the press. We're currently deploying our system with Air France and have another half a dozen airlines trialing the system. So basically, what's new is that we've developed a laser technology positioning system that allows autonomous navigation of the UAVs inside hangars, so without relying on GPS. So basically, for those who know the technology words, it's basically bringing laser SLAM to an industrial level to enable automatic inspection of the outside surfaces of aircrafts.
Okay. Okay, could we have the computer projecting on screen?
Okay. Yes. So hello. So my name is Adolfo Suarez. I work at Airbus. I have some kind of very strange issue with the presentation. I don't know where it went. Sorry. So yes, I'm working at Airbus in collaborative robotics for several years, and I wanted to just explain a little bit what we do. So these are reality. So we have factories full of robots and factories full of people, and we have fiction of what we think robots can do and actually can't. So we still do not have robots that can put a shoe in a feet of a woman, or robots or exoskeletons that carry a car. And in reality, at Airbus, we have people working all around the plane. So a lot of people working, and typically we don't have robots among people. So the vision we had was to put robots between people and to have them collaborate. So this is our vision. And we have defined several levels of collaboration. So as you can see, you have the level 0, where the robots are in one space and the people are in another one. The level 1, where they share the space, but they are working separately. Level 2, where they are doing the same operation but not the same task. Level 3, where they are doing the same task together. And level 4, where they are one. So robot and humans are one. And at each level you see different levels of autonomy, and in particular in level 1 is where I think there is the best business case today. So we are focusing a lot on that in a kind of interaction. And at the end, when we put robots in the factories, this is what we try to do. So we think that we need to keep up with the regulations. So we need robots to be safe, to respect the environment, the quality. We need robots to be cost effective, to keep the flexibility of our factories, to improve the lead time, to be modular, and we need the robots to be accepted by people. So we need to have good working conditions and people to not be stressed around robots. So we try to look into all of these aspects together. So this is what I'm trying to do.
Okay, Rachid, maybe could you explain what you are doing and maybe sum up all the 3 or 4 main challenges we have in this issue of collaboration between robots and humans?
Well, I'll just say a few words and then we'll go to discussion essentially. So, so I'm a researcher. I'm working on human-robot interaction from the point of view of the decision, I would say, the decisional aspects of a robot. What decision should a robot take when it has to interact with a human? And we can summarize this today in something that we call a joint action. Okay? Humans are used to work together, to do joint actions together, and the challenge is to think on what is needed for the robot to allow it also to do joint action with human at different levels, to assist human, to work with the human in different situations, from the factory to the home, etc., etc. So I'm very happy to be here to discuss with this to the questions.
Okay. Maybe this morning we didn't speak a lot about economy. Maybe a first question to everybody. What does robotization save? Could you give 1 or 2 key examples in various sectors?
Yeah, I have quite a few interesting figures on this one. To give an idea, aircraft inspection, so we're talking about inspecting the outside surface. On a large aircraft, it takes currently around 8 hours with 5 to 10 people. So that's an 8-hour inspection time. With a robotic system such as our drones, we can bring that down to around 20 minutes. So basically, we're reducing inspection time from 8 hours to 20 minutes. Now, when you know that unplanified inspection, or when it's non-planned maintenance, the grounding cost of a single aircraft is around $10,000 per hour. So, for example, in this situation, robots can save up to $70,000 by reducing the grounding time of the aircraft, but also bringing the passengers back to their destination faster.
Yeah, there is a saying which is maybe simplistic but which is not so stupid, I believe, and that is that robots are useful for the 3 Ds: dull, dirty and dangerous activities. Dull would be, for instance, dull could be long-range surveillance activities where it would be very painful for a human to, take hours inspecting or making the surveillance of a very long railroad, for instance. Dirty could be if you have, for instance, a nuclear incident, as I said this morning, and where you want to send robots instead of humans, and this is dirty and dangerous, by the way, you prefer to send robots in this case. And finally, I could say also, and this relates to what Matthieu said before, and that is the cost could be very effective by replacing other means by robots, for instance, for surveillance activities or others.
Maybe in other domains?
I'm not sure if I understood the question. Was it where robots can be useful?
Yes, and robotization. I think we know that we save money, we save time, we save things like that in several domains. And maybe not the case in the health application, but if you
I mean there are certain, and Alin, I think you showed a figure also about demographics and costs in the healthcare sector. It was specifically about the aging population, but also in other areas. I think one of the there may be economic motivations doing it, but there's also a great potential in terms of quality of life. If you, for example, think about using robots in education and therapy, it is not necessarily about replacing people and cutting costs. It is more about increasing the quality of the practices that are already there and the efficiency of the education and the therapeutic approaches, and to also increase them in a context that is good for the quality of life of children, for example, to make therapeutic approaches fun, to make them useful.
Thanks.
So maybe you like to say something.
Yes, I tried actually to highlight some aspects. In industry, actually, there's a big change, and people are so much worried about robots destroying jobs, but we have to be aware that without automatization and to a large part robotics, we would not have production in Europe probably at all at this time. So all the car manufacturers wouldn't manufacture in Europe if they would not use the robots, right? And what we see now is that, I mean, a certain type of activities had been very well automatized, but as soon as the number of identical pieces goes down, the classical robotics does not work anymore. So you can do with robots 10,000s or 100,000s of pieces, but you cannot do 100 or 500 identical parts. So the goal is now, and it's reachable, this goal, to go down to lot sizes of about a few hundreds. And then again, the game changes completely. So for example, the final assembly in car industry is still manual to 95%. Because the diversity is so large, you know, each car has a different inner furniture and so on. So I think production down to, you know, small lot sizes, SMEs and so on, this is going to come. The other big thing is logistics. If you know, Amazon is setting more and more on robots, on mobile robots, and you know, I mean, ordering also food over internet becomes more and more a custom, and these are huge logistic systems. And the work there for the workers is not an easy work. Partially they work at minus 18 degrees, you know, for frozen food. And this is also an area where robots come a lot into the game in logistics. And the last one is healthcare. It was mentioned already, but we have seen also surgical robotics. So there is not so much about saving costs, but it's about increasing the quality, because you can just provide less complications, higher accuracy of surgery and so on. So these are the main areas, and I think the personal robotics, you know, I mean, the home butler will come late because there's a high cost pressure. So how much would you pay? Maybe 10,000 euro, I don't know. There's a lot of functionality for 10,000 euro, which has to be there. But the diversity is huge, right? So it's a very complex task and a high cost pressure. So I'm not very optimistic about that, but the other areas are moving fast.
I would add just one word on this. I fully agree on all what has been said on the main uses, I would say, for robot. But let's give an example. For example, I've read and seen things that the washing machine at home was a huge benefit for the quality of life in society globally, particularly for mothers. Huge. And so perhaps this also will come through better quality of life for having robots there. And also, I didn't need this object before having it. So this aspect, it can come for, it's not really a need, but we will use it and we'll enjoy it.
Yes, I can hear that, but you are explaining that robots will come in domains that where they are not today, and it's not only to replace humans for dirty jobs. And well, we can see in some study from the MIT, for example, that each time you introduce one robot among the 1,000 human jobs, you destroy 5 human jobs. And you see also in some press release that 70% of jobs in developing countries will be killed by robots. So what's your feeling on that? Do you think that you are killing all the jobs in our countries, or?
Yes and no. When agricultural machines were introduced in the last century, 40% of the people were farmers, and after that revolution, 2% of the people are farmers. So 38% of the people changed their way of life, which is huge. And they still have a job, and they have better jobs or not, but the society adapted. When computers were introduced, a lot of people lost their job, but we have Google, Amazon, and other guys which are making a huge amount of money and improving the way of life. And robots will do the same thing. Some jobs will be destroyed, and some opportunities will be created. And I would say it's impossible to imagine which of these new opportunities will emerge. It's just, we cannot know which will be the new jobs. We saw one this morning. It's the new job. It's the choreographer of robots. So this didn't exist yesterday, but now we have people doing choreography for robots. So new jobs will emerge, and the value will be created, and something will be done with that value. So my feeling is positive.
I can have a comment on this quickly. I think first, I don't think it's the robotics we are speaking about that is first concerned. There is simple automation that makes jobs lost. Very simple automation that is used today. The automatic machines for buying tickets, etc., etc., etc. When you print your boarding pass when you go to the airport, etc., etc. So it's not really the robotics that is killing jobs. It will come perhaps, but it's not only this. There are a number of other disciplines that effectively will take jobs. But the main thing that I would like to say about this is that if these machines effectively do the work instead of us, it should be good if we share the benefit. That's all. The issue is simply sharing the benefit of the robot working. Okay? It's not. I want the robot to work with me, but I want some benefit. That's all.
Yeah, just to add a word on this, I mean, I completely agree with this. Currently, and I still believe to be the case for at least the 10 coming years, each time we put a robot somewhere, the job we're removing, if we are removing one, is not an interesting one. And clearly the goal or the real question is how can we ensure that the gains brought by the robots are redistributed to the population and to the workers. So an easy one is simply the time and the amount of time people are working, but there are many ways of actually doing this. And also current workers, I mean, I'm speaking here more for aerospace industry, which is the one I know. The workers can do many different tasks. And each time when we, for example, with our drone inspections, visual inspection is less than 5% of the actual tasks. So we're basically removing for all the workers one boring and dangerous task. Some of them are gaining a new interesting task, which is actually using such a system, because they're actually going to be the people who are going to use the system. And for all of them, it's basically a minor change. And that's how the robots are going to continuously and gradually, I believe, improve the actual quality and the interest of the jobs people get.
Yes, so I would be humble in my answer because I'm not an economist, but it seems to me, I agree with what has been said, and it seems to me that it will be more a job change than job destruction. I just take two examples. In the cinema industry, there will be huge use of drones to take pictures because they have maybe an accuracy and a repeatability which makes them very attractive. And so I believe we will move from job of having the camera moving to a new job which would be, operating the drone, or maybe a new art which will be to make the drone move the way you want to make a nice movie, right? So it's a new art, a new job. And another example is the one I took before, the long-range surveillance. Maybe we will move from doing it on a car or a manned helicopter to a drone. But in this case, you will need new jobs for programming the drone, operating it, and maybe image interpretations or the interpretation of the post-processing made by a computer and so on. So you will create really new activities. And I believe, in the best cases, very interesting new activities.
I think I have similar thoughts to some of the previous speakers. I've recently attended a couple of meetings in London and in Cambridge about the future of work, where we had actually experts sitting there who have written books and giving lectures about what would be the consequences of technology, and do we need a universal income where everybody, regardless of whether they work or not, have a certain guaranteed income. And I mean, I was more there as a robotics expert. I'm not doing research on those sociological and economic implications. But what I learned is that that for me it's really interesting to see in the future. At the moment, as it has been mentioned, if the emphasis of is just about profit maximization, so to use technology, even simple computer technology and robots also, just to make more and more profit, then this profit will not maximize those who become unemployed. So the question is, how can we balance that? How can not just a few huge companies who will become ever more rich beyond what they ever need in their lives to spend, how can this be balanced? And I don't have an answer. As I said, I know people who are writing books on these topics. I could never write a book on it, but I just hear when talking to people that there is a lot of discussion. And it needs to be looked into really, really carefully, because otherwise we will have this future that we sometimes see in science fiction movie with these really masses and masses of unemployed people, and only the very elite who have access to education, access to wealth, and clearly no one wants that. And but yeah, it's certainly important to have this discussion, but it is more, I think, on a political level, on a society level, and not so much asking expert roboticists on how we can solve that problem. We have insight in the technology. We can point out the limitations and the strengths of that technology in possible scenarios and how it can be used. But we ourselves personally cannot solve political or societal problems.
I think everything has been said already. Yeah. So increasing productivity. I mean, the story is as old as industrialization, right? Every 10, 20, 30 years, there's a new technology which increases productivity, which is intrinsically not bad, because we can get the same quality of life with less work, where nobody complains, right? Then people get unemployed, and this causes social tensions. And those tensions has been huge 200 years ago because there haven't been a social system. And today we have a social system, and so I agree to you, it's a political question, it's a social question, and our part as technology people is to inform society about what is feasible and what not, what are just science fiction expectations, what will happen the next 5 to 10 years. And everything else, I think it needs to be solved by the society. So if we all work less, but have the same level of wealth, it's not bad by itself, right? But how do you do the transition? And what happens is that after like a few years, people start to invent new fields, right? We discussed yesterday, nobody of us was aware that we cannot live without smartphones, right? But this is a true necessity today. So probably new fields will emerge, and probably the society just needs to balance, this period of time in which people reorient. Which is a problem, probably, is the fact that, the qualification cannot change that quickly. So car driver, which is maybe replaced by autonomous car driver, won't become a robot programmer overnight, unless robot programming is so easy that everyone can do it. And then this is again a technological task.
Okay, thank you very much to answer to this difficult question for scientists. I agree. Maybe going back to science and research, as long as you make cooperation or collaboration between robots and humans, you have lots of uncertainty in the behavior of the human. So is there specific research on this idea of uncertainty, or could you a little bit elaborate on that?
We could perhaps start from there, because okay, so I will start. The question was linked to when the robot will have to work or interact with the human. There is the uncertainty from the human side, I would say, because the human is uncertain. The human can change his mind.
I hope there is none from the robot side.
Exactly, human is not controlled. Human has his free will, I hope, etc. So yes, there is. In fact, it's an emerging field that appears more and more. This we mentioned it. It has been mentioned a little in some of the presentations concerning what is called acceptability, etc., etc. But clearly, there is this issue of the robot permanently adapting to the human, permanently aware and adapting to the human. Sometimes even it could be proactive, proposing things, etc. And it's a field that is emerging, where there are conferences on human-robot interaction and human-robot, I would say, working together, etc. So it's clearly a field that is emerging. And it doesn't concern only roboticists, but also psychologists, even philosophers are interested in this field. Okay. And I give...
Okay. So indeed, this interaction aspect makes the robot programming difficult, but also makes the use of the robots difficult. And what we notice that when people start using robots, they have sometimes difficulties to understand, so to say, the mental state of the robot. So it's a complex machine. It can have different behaviors, different states, and it's an active field of research. How does the robot display to the human, the options it has, the state it has, whether it's, in a cooperating mode or it's doing the task by itself. And this makes robotics also very interesting, because there you don't have only the engineers and the programmers, but you need psychologists and you need designers. And again, going back to the example of the smartphone, the success is the design of the interface. A computer, which by itself is also complex, looks very simple because we have good interfaces. And this is the big question: how can we design robots in a similar manner? And we had some example of, you try to embed some behaviors of children, of animals, of humans, and use that. It's one approach. There might be some other approaches, but this is the big difficulty. Industrial robots, the programming is kind of sequential. You do this and that and that, and sometimes some events happen. When the robots interact with the humans, it's always changing. It's the exception becomes the rule, and but this is still a quite active research topic. We do not have valid answers on all those questions yet.
I think humans are the most complex, unpredictable, and dynamic environment that a robot can possibly face. And that's exactly why these difficulties arise, because if a robot interacts with the person can at any point basically do anything. Stand up and leave, fall asleep, become bored, look at something else, losing interest, pick up a book. Now, in human-human communication, we are very good in judging, is someone still interested in talking to me? If during the coffee break you talk with someone and you are using lots of not just verbal cues, what someone says, but how they say it, but also how do they look at you, where do they look, what about their non-verbal cues. So we can easily judge how to, is someone engaged, and if they might lose interest, how do we re-engage them? Now, robots have this difficult task in figuring that out, reading all of these dynamic, complex cues, keeping the engagement. And even with the work with the children, although I said previously, we can very much rely on the fact, I think, that generally most children love robots, including children with special needs. But even then, in repeated interactions, you are often facing the problem of how can you keep the engagement going, unless the robot changes its behavior, becomes again more interesting, in the same way as a human in a conversation, when they realize, oh, maybe what I said just wasn't very interesting, then they think of something else. And this is really, really difficult for robots because it requires almost human level understanding of behavior. And that's really, really difficult, but it is scientifically a very interesting challenge, and many people are working on that topic.
Just to clarify this point, I think the robot has to do a task, okay? But we add two aspects to this. First, it has to do a task in a way that is legible. The human should understand what the robot is doing, okay? So not only it has to do the, I would say, the function, but also communicate about what it is doing. And also, the robot should monitor the human, should see if the human accepts what it is doing, okay, somehow. So there are these two aspects. The robot should add communication in its action, and should add perception, more elaborate perception, concerning the commitment, what Kerstin has said, that the human is engaged in the task, etc., etc. There are these two aspects that are added to the standard robot performing the action.
So, as compared to my colleagues, I think I have a very narrow way of seeing interactions between humans and robots, because in my job, the main interactions between human and robots is when the human is the pilot or the supervisor. So it's a much narrower way of seeing things. But in this case also, the uncertainty in the behavior of the human being is very important and has to be taken care of. I spoke this morning about this problem when the human supervises an autonomous system. I can mention just another phenomenon, and that is when it is very famous in civilian aviation, for instance, when the human being focuses very much on a very particular piece of information and forgets about the rest. This is called the tunneling problem. And so we need to design new interfaces to catch the attention of the human being so that he avoids, tunneling and focusing on very particular piece of information, so that he keeps a very good view of the situation as a whole. And this uncertainty, in fact, it could be dangerous if we cannot deal with it.
Yeah, I have even a more ground level example. What we try to do to manage this uncertainty, because there's also uncertainty sometimes on the robot side, because sometimes the robot, generally because of the environment, is not going to be able to accomplish his mission. So what we've tried and done, for example, on our UAVs, is we have a few very simple symbols and tasks. Basically, the robot is always giving his status, whether everything is okay or not. So, for example, the robot is basically going to communicate either green, everything's fine, or I have a problem. And the other one is to give simple interactions that basically always work. So, for example, one of them is obstacle avoidance. The operators, we ask them to actually test it from time to time, and it's a bit in a way that you could pet a dog. That's a way of checking the robot is still answering, and we basically force the interaction between the person and the robot. So we're going to say, when the drone takes off, please go and check the obstacle avoidance once. same thing. For example, there's always a few functions, very simple, but that always work. And this is a very basic, of course, solution, but it partly handles the fact of getting the robot and the human, at least at the startup of the mission, on a, let's say, on a communication basis, or on the same level.
In terms of factories, when we have the standard industrial robots, they will perform the same task over and over, and the world is not moving. So everybody can know what the robot will do next, because it's the same thing it did 1 minute ago. Once we introduce humans, as was said before, everything changes. And because the world is changing, the robot can no longer pick the part here, but sometimes it will pick it up at a different position. So the first thing about this is that we have to plan the actions, and it's no longer a movement that was programmed and tested and validated. It is a movement that will be generated in line. So I can go pick the part like this, or I can put my elbow in his head, right? And this has to be taken into account by the robot, and Rachid did a very good job on creating social behaviors that need to be introduced to the robots. And it's also very important for the human to know when the robot will move, because it's not the same thing to see something like this than to see something like this. And if you surprise the human because the way the robot moves, you lose a lot in terms of trust and in terms of acceptability.
Okay, maybe we can take 1 or 2 questions from the room. No? Yeah.
I just wanted to react on some of the discussion. Just to mention that yesterday in a workshop, we were talking about the ethical aspect of human and robots interaction, specifically in the health system and environment. And we approached a number of things, and one of those was that the robot was a machine and was always to be seen as a machine by the human. And sometimes when we heard about a number of applications, there was, well, my feeling here, the tendency that the human had to be adapted to the machine. And yesterday the discussion was very rather strong on the fact that it was not the human that had to adapt to the machine, but the machine that had to be adapted to the human behavior. And so just to say that ethical issues we have touched, and you just touched one line and said we have no time. We had a full afternoon on that yesterday in the domain of what is called a societal platform, where there is a discussion between public and scientific people and people working in a certain domain. And the second thing I want to say still about the ethics of it, you talked about the future of work and how the robots and a number of other technological domains are going to change the perception and the reality of the work. And I am one of the 15 members of the European Group on Ethics of Science and New Technologies. That is a group of people who are in charge, or it's a body, advising the European Commission on ethical aspects of science and technologies. The group has been renewed, and we just had one meeting last month. And one of the topics we are asked to work on is the future of work. So you said that there was some, society had to think about not only the technologies, people in technology should not be away from this discussion, of course, but not alone. And so this group on ethics of science and technologies at the European level will be asked to think about all these domains, not only robotics, of course, but in general. So I just wanted to mention that because it was very related to your discussion.
Other questions?
what would you think about the situation in 20 years from now? Will all manual work be done by robots?
Who wants to answer to this? Who wants to answer to this question about?
I can just give my personal insight for aircraft industry, and it's quite similar in naval industry. Many of the tasks in maintenance are different and rare and unplanned. Basically, you're going to have maybe 20,000 components on the aircraft. You have to change one of them. And even if programming a robot is extremely easy, and I'm certain it will get easier, I don't see in the coming many years being able to program a robot to dynamically disassemble maybe 20 components to get to that 21st component that's damaged, replace it, and then reassemble everything. So maybe in actual manufacturing and production, yes, but maintenance is an extremely big, for example, in aerospace, there's more people maintaining aircrafts, many more people maintaining aircrafts than actually building aircrafts. And all those jobs are basically unreplaceable by robots.
I have a small comment and I give to the others. In fact, I think we have seen it through the examples. Manual work is very difficult. Manipulating objects, doing this, which seems nothing, it's very difficult. And I think the jobs that are threatened now are less the manual work than the services. Services, for example, the lawyers could be very anxious about their work, okay, because there will be AI systems that could replace them, and perhaps the CEOs of companies could be more more anxious, because I think it's easier perhaps to replace the CEO than to replace the guy who is locking the doors at the end of the day. Though in some aspects, it's not that simple. It's a little provocative, but in fact, the manual work is very challenging and very difficult. And I think what Alin has shown with this difficulty, they are starting to master the contact, okay, and the manipulation, but it's still a big task.
Maybe just a quick comment. I think there are three aspects to this question. There is a purely technical aspect, and as we all saw from this morning, there are some technical challenges, but many things can already be done today, depending on the domain and the task. But then you have the safety, and I think this is really the key to everything. Not only the safety that you can provide for a given task done by a robot, but also the safety that you can prove, the guarantee that you have on the safety. And this, I think, there is still a lot to do to improve this. And finally, the third term is the society, and I would say / political aspect. That is a decision that the society has to make. So you have what we can do, but then we have the safety, and then we have a decision to be made depending on the society, what people want for their future and the choices, societal choices we want to make.
Maybe we have the chance to have in the room Thomas Peruz, who make the performance this morning with the robot. Could be interesting to have an artist view of all these questions.
Okay, thank you. Yeah, in fact, something I saw about putting robot on stage is the presence of the public, the audience, and in industry, it's the customer. The customer has a place among the tasks done by the robots. In fact, more and more, what I see is the distance between the customer and the task is very, very short, thanks or not thanks of the robotics. For instance, when we talk about the automatic cash, in supermarket, and when you have the automatic cash, in fact, the big issue is that the cash is a normal cash. It's just that the customer does the job. This is not a robotic task. It's much helped by the cash, but the work of passing the product is done by the customer. So when I think about robotics, I always think about where the customer is and why we do automation for the industry. Yeah, that was my point.
Any comment on that?
I was just trying to make a joke about this. I think we have to leave the fun for us and the work for the robot. That's the first thing. And so we have in fact, essentially to make the machines work for us, essentially, and also for our fun. Why not? Not only for working, for art, etc. For all these fields, we have to pay attention to this. But it's true that in some situations it's becoming closer. In a sense, look, we have the Fab Lab here, where it's this which is coming. You have printed your robot somehow. It's very interesting to see how this is effectively coming closer, and this is somehow interesting.
From my point of view, some of the tasks today are always the same. You always repeat the same thing, which is the case for lawyers and for some manufacturing tasks, while some are really challenging and change all the time. And these will not be replaced, but they will become more and more expensive actually, because the rest of the chain depends on these few people doing a very sophisticated job. So somehow the humans will add higher and higher value to the chain. And I see, it's not maybe a good example, but today we have airplanes that can land autonomously and take off autonomously, and this has been there for more than 10 years, 20 years, and we still have the pilots. And society is not ready to leave the pilots away. We will still have pilots on the plane because they have an added value, a very high added value when there is a small issue and the machines cannot solve it. So we will keep them in their position for a long time. We have kept them in the position for a long time. There have been attempts to not have pilots in the planes, and this was completely refused by the society, by the people, by the companies, by everybody.
Okay, maybe a last question, because we have nearly finished. For each of you, what will be the next big step, the next progress in your domain in terms of cooperation between robots and human? Your next challenge?
So, I mean, I study human-robot interaction, so I depend on having systems, having good robots available. I mean, really, really good robots, but also safe robots. So if I have robots that have a certain size and certain weight because they have to do certain tasks, safety is a big, big issue. And Alin mentioned this issue of compliant arms, but for me it would be a big step to have more like that, more of these real-world systems that are intrinsically safe, that also can be proven to be safe, because that would be a big step that would, and after my talk, somebody over there who has left now asked that question, well, in your robot house, how could you make it even more realistic? Well, put it in a real home. At the moment, we can't do that. I would like to have systems, not toy systems. Sure, you can put a toy into someone's home, but these more substantial, like these companion, these mobile manipulators that you can put unsupervised into someone's home, which is not only safety from the hardware, but also from the software. That would be a big game changer, where we can do many more experiments.
So if I should highlight one, I've shown some slides of interaction between robots and humans, and generally between humans and machines, because very many people think about robots as, you know, the humanoid robot which stays opposing to the human, and, you know, there's this opposition. While I think that the reality develops in a different way. We are looking very much into human-machine interfaces, you know, body extensions. Some people like to speak of cyborgs, some are scared of cyborgs, but reality is that those interfaces to the body of the human becomes better and better, and we should also imagine the humans being very closely linked to the robots, to the computers, maybe also humans network to each other in a different way, and this will definitely change the game. I mean, if we can, the bottleneck between the computers and us is the interface. The computer communicates very quickly. I mean, humans are good in communication, but the interface, we are still typewriting on a computer. I mean, it won't hold for long, I guess. And this will revolutionize not only robotics, but I think the technology in general.
Sorry, it will be maybe a little bit tarte à la crème, but I think an artificial intelligence algorithm able to deal in a most generic way with unpredicted events, meaning the unpredicted behavior of the other robots, of the human, as we said before, or exogenous unpredicted events. And if I say so, it is because today we have like many ways of dealing with particular events, as I spoke this morning. But I think having something quite generic, you know, quite universal to deal with many different types of unpredicted events would change a lot.
Yeah, I see maybe two things coming, or big changes. One will be the notion or the capacity of a fleet of robots. Currently, when we deploy a robot that moves, so for example, either on the surface, a ground robot, or flying robots like we do, usually there's only one at a time, so it's currently easier to see the interactions with people. Soon we're going to have more and more of the robots, and they're going to decide to do their tasks automatically. Basically, currently, when a robot takes off, all the people around know it's going to take off. Tomorrow, you're not going to be expecting it, and in your airport, wherever you are, you're going to hear a robot suddenly take off from somewhere, do an inspection task, and land. So there's going to be a big change, and I think there's going to be a first step probably where the robots will be always out of touch basically of the people. So you're going to experience, you're going to see it anywhere you be, even at the shopping center. Soon you're going to have drones taking off, doing an inspection mission and landing, but you won't be able to touch them, they'll be far away. And the next change is that the drones are actually going to start getting closer to us. And this is going to be more complicated because there's going to be the interaction, the real interaction, but which is why I don't think this step is going to come for at least 5 to 10 years.
What I see as a big change is what Thomas Perus explained today. He takes 1 week to program a movement that lasts for 1 minute. And Alin told us he takes 2 days or 3 days with 2 PhDs to program something that lasts for 1 minute. And I have the same issue. So the big change will come when we can program a robot in 1 minute to perform something that lasts for 1 minute. So in same amount of time. And what I see is that we are going in that direction. Robots become easier and easier to program. But they need more autonomy. And another need that is out there is that today we have 10 or 20 different robot providers and 10 or 20 different robot programming solutions. And nobody knows all of them because they're all different. And when you drive a car, they all have the same interface, right? And I can drive any brand of car because I have a driver's license. And we need the robots to propose this single interface so that everybody can use it.
If we speak specifically about human-robot collaboration, not the functions of the robot itself doing a task, but human-robot interaction, I think the image is the robot and the human are sharing space, sharing the task, okay? Working together and sharing space. And for this, I think one big challenge is situation assessment, the capability of the robot to understand what's happening in the task, in the mental state of the human, etc. And I think it's a very big challenge, very difficult challenge. Of course, there are others, but this one is very challenging. Okay. Situation assessment.
Okay, thank you very much for everybody. I think we can thanks our keynotes and roundtable people, and thanks a lot.
Thank you very much, Gérard. Thank you very much to all our speakers, the keynote speakers and the participants in the roundtable. We are now going to close the session. There are 8 posters on projects on robotics, focused as well on the interaction between humans and robots, or multi-robot cooperation. You can find these posters at the entrance of the festival, on the Aerospace Valley and ONERA booth, as well on the Cube, the small conference room, the Cube, and at the Fab Cafe. And we are going to finish with a cocktail at the Fab Cafe, and I leave the floor to Anne Cambon for the last word.
Don't go away, stay there. I don't want to prolong the session. You have had a long morning. Just thank you also to you to have been here, and also those who left a bit before. And what I want to say is just 3 things to the end. I think that this was an illustration, this rencontre, an illustration of the collaboration, the partnership between Aerospace Valley Cluster and ESOF and the Université Fédérale for making this rencontre together. This is happening for the previous rencontre was in March on big data in health. The next ones will be in the autumn about agriculture, and that will be with INRA, Agriculture and Nutrition Today, and another one about water and energy. So that's the way we prepare this ESOF, by making meetings together with the partners on topics that will be high topics, hot topics at the moment of ESOF. So there will be robotics in the ESOF program. I hope all of you and our speakers will be there and will contribute to their expertise and their ideas and discussion. And the last thing I want to say is, giving you this rendezvous in 2018. Now we have the Fab Lab. You have enjoyed already the noise and the sounds of the Fab Lab of the morning. So I hope you will also enjoy the posters, the drink, but also something about the Fab Lab Festival. And you heard before that in next year, ESOF will be from 9 to 14 of July, and the Fab 14 will be after that in the same July month. So that will be next year extremely lively, important, and with an interaction between science and society in the next year. And I think that's exactly the spirit of the Fab Lab Festival. And I would like to say again, thank you also to the organizers of the Fab Lab who hosted our meeting in this environment. So thank you very much.